indeed streaming. It says I'm offline. Still says I'm offline. Wait a minute. Oh, here we go. Hey, an ad. Playing an ad on Twitch. Okay. Interesting. Okay, wait. Hold up. Okay, that's just background noise. Okay, cool. I don't know if, huh. I don't know what's happening. Alright, we'll just hit that for now. We'll check it out on delay. But anyway, okay. So, this stream is geared towards the Rust programming language. I'm writing some Rust code, and what I'm actually doing is rewriting some projects that I did in C++. They're pretty simple projects, but they were for a class. But I'm going to rewrite these and see what we can do with Rust, seeing how it's such a different language. I really want to try. I want to learn it better, and there's no better way to do that than to actually write a practical application or something. Granted, it was an assignment; it was a little contrived, but they all come out of the Elements of Computing Computing Systems class in that NAND to Tetris book. So it should all be pretty interesting. I'm working on the assembler at this point, being the first project, also one of the simpler software projects. So hold on. Okay, so just kind of a general overview of what the assembler is supposed to do. It's supposed to take in this hack assembly is what it's called, this hack assembly language, and it's supposed to convert that into some binary opcode that can be run off this emulator that comes with the course materials. And so essentially what's happening is the overarching design that I came up with has the input file being directed into some sort of lexer to tokenize line by line, because each instruction is on its own independent line. And then from the lexer, we pass it into the parser that determines the command type. And that parser has a symbol table to keep track of symbols. In the first iteration, we're not going to deal with symbols. We're going to only deal with converting straight assembly to the binary representation to the opcodes. But we are going to want to add a symbol table. That's kind of like phase 2 of the project, so that we can create, symbolic things and use those. And then finally, we're going to redirect that sort of parser output to a code writer that's then going to write to a file. And that file is going to be kind of our final thing. That's going to be where our binary opcode goes. So I'm moving some stuff around because I want to plug in my other monitor, because in case people come into the chat box. Hold on one sec. I'll be right back. Okay, sorry about that. I am getting this other monitor plugged in. I think it actually changed the resolution of my main display. So let me change that back, because I like 1920 by 1200 rather than the Retina resolution of like 1440 by 900. I like more space. Okay, cool. So everything looks good. I'm gonna drag this over. Oh shoot, where is this? To this other monitor somewhere. Okay, cool. All right, sorry about that. Sorry for the inconvenience. I think we are good to go. So let's take a crack at it. So this is an educational experience for me as much as it is for probably some of you watching it who may or may not be familiar with Rust. I'm not doing anything too crazy with it. Not doing any sort of concurrency awesomeness or anything like that. It's going to be a pretty straightforward input-output sort of program. I've been working on this for the past couple days, and I kind of want to practice a test-driven sort of scenario with this kind of development. So what I've done is some cool stuff. Hold on. It looks like... Oh, no, okay, it's 1920 by 1200. So it's not the greatest streaming resolution, but that's the way things go. But anyway, so what we're going to do is we're going to start taking a crack at it. And so we'll have some fun with that. Okay, so I worked on the parser quite a bit over the past week or so. So I can kind of show you guys the code for that, and we can kind of review it and go from there. So if we take a look at the code for the parser, or for the lexer, for the lexer, essentially all it does is take in some sort of read attribute, and what it does with the read is it reads it into a string and then breaks it up on new line characters, maps it to a token, allocates a string from that token because that returns a ref string, returns some sort of reference to a string. And then from there, we're going to collect it into a vector of strings because that lexer is going to own those strings. So we are doing some memory allocation there. And then we have an iterator function down here on line 25. And essentially all that does is return the iterator to that vector. And then from that iterator, we return references to strings through the iterator. So the idea here is to be able to do something like this in this test right here, this iter lines test. So we create some sort of new lexer, and we mock it with some simple assembly line commands here, and we tokenize it that way. So we can test the tokenizer to make sure the output's correct. But then what we do in the iter lines is we grab a new lexer instance. We create a new counter because we're going to validate each one against that test tokenized result. And me being me, that's the only way I could figure out to brute force it. And then from there, for each line that's returned from that iterator in the lexer, we assert equality that line is equal to the tokenized result given that counter from our static array of static string slices. And then we increment the counter and continue the loop. So that's kind of what the lexer is doing, and that's what kind of makes things a little nice there. And so what we're gonna tackle now for I don't know how long, but for a while, we're gonna tackle the parser phase of this. We're gonna interpret what the command is. We're going to convert it to its bit field for the opcode. And finally, we're going to add symbols to the symbol table if we get to that phase today. I don't know how quickly things are going to go, but we're going to kind of see how somebody writes a Rust program, or how I do. And I'm not the most experienced Rust programmer. I've been following the language for probably about 1.5 years now. So we'll see what happens. And I'll try to talk through it as best as possible, but I've kind of explained the background of the project enough, so let's dive in. In case anyone's wondering, I'm using just regular command line Vim and tmux for window management. I actually have a Ruby guard file set up so that when I save files, it'll run cargo test, which allows me to test my code. What I want to check is whether it actually works in its current form. It does not. Why? Interesting. All right, so I have a few errors right off the bat. They're all in the parse.rs. I wonder what changed. Oh wait, it's here. What line were those errors on? 14 is what it looks like. We're gonna restart guard, but let's take a look. Line 14. Oh, we just return a parser. Yeah, so I wanted to do an abbreviated syntax, but that's not the right thing to do. Right, because we actually have a struct with fields. When we construct it, we need those fields to exist. So we're just gonna start with the program counter set to 0. That's what PC stands for, because we want to keep track of where programs are. So when we do conditional jumps within the assembly, we go to the line that we want to be at. So if we go back to test, everything looks okay. It passed the create parser, which means that we're not getting any errors constructing a new parser, which I sure hope we wouldn't, but so everything looks good there. So what I actually need to do is go grab my book real quick because the book has the opcodes that we're converting to. I forgot it. It's just on the other side of the room, so I'll be right back in like 10 seconds. Okay, so I grabbed the book. The other thing I could do too is consult my old C++ code. That's obviously a possibility as well. Okay, so I can actually kind of show it off. Some of the old C++ code that I have. It's in the second window. It's a lot more code. This is just the parser. I kind of combined the Lexer and the parser in the C++ version of it, so it came out to be about 239 lines. But because I'm using iterators in Rust, it actually makes things a little bit more concise. I'm just not sure how much it's going to take for these getting sort of compare bits and whatever else. But the big things I want to know from here are L commands and A commands, because those are going to be I'm going to use similar regular expressions inside of my Rust code, but I need to import the regular expression crate. So what I'm going to do is open up my cargo.toml file, and we're going to create a whatchamacallit, we're going to create a dependency. We're going to specify a dependency. So it's regex, and I don't remember the syntax for this. I think it's dependencies.regex, and version, let's just grab the latest version. Let's see if that works. I don't remember this off the top of my head very well, but cargo build. Let's see, registry. Okay, yeah, so that's it. It pulled in regex syntax v0.2.1, and so now we're gonna roll with the regex library, which is good news. Oh, okay, all right. This is the other thing I was curious about too. That should be camel case, not snake case. So I should change those. And I have some unused imports, but I will deal with those later. The Rust compiler likes to look out for us. It's kind of nice, kind of not. It depends. We'll go back to guard, and let's just close that buffer down. So let's change these back to camel case as the compiler would like us to. So that's good. And yeah, I still have the symbol table there, but we're not going to be using that. What we're going to do is we're going to want regular expressions, but to do that, we need to import that crate into our global lib.rs. So we're going to go extern crate regex, because that's the crate we want. If we go back and check the test, nothing failed, so we're good to go there. And let's go back to our parse. And from here, we're going to create our regular expressions, probably in the constructor, and they're going to be like single instances on the parser itself. So what we're going to do is we're going to say command regex, and we're going to call that just a regex, and a command regex, another regex. I don't have to use regular expressions. I just prefer to, because they're indiscriminate, in particular about what I'm matching. So I typically work with regular expressions whenever I can. It's a personal preference of mine. Some people don't. Some people use string manipulation functions, and there's really no wrong answer to that. But oh shoot. All right, so now my big question here is, let's check out Rust regex. I want to consult the documentation here and figure this out. Okay, here we go. So extern crate regex, we did that. And okay, it's just regex. I couldn't remember what the use was. So use regex, that's going to be our struct. So then we can specify it like that. And then, oh my god, my laptop is going crazy. It is getting warm, but that's okay. We'll keep going. We'll keep pushing on. If anyone has any questions or comments or anything, feel free to drop it in the chat box. I'm watching it, so I'll respond to them as I see them. Sorry for any of the background noise with the fan. It's kind of unavoidable, and it sucks. I understand, but we'll just have to bear with it. If I'm too quiet, or if something with sound is up, let me know too, because I'll try to fix that. But anyway, all right, so let's construct our regular expressions. So we have an L command regex, and so what we're going to do is we're going to call regex new. And from here, let me check the documentation again. Yeah, so we're going to use a raw string, and we're going to specify the new regex. And we're just going to call unwrap, because if it doesn't work, we're going to fail fast, and we're going to get out of there. So we go regex new, and then here's our raw string. And we're going to cheat and just call unwrap. We could do some more detailed error handling, but right now we're going to be quick and dirty. We can always clean that up later. And same thing here. So now let's actually flesh out that regular expression. So this assembly language, most of you are probably not familiar with. It's nothing like x86 or MIPS or any other common assembly language like that. It's very strange. Again, this all comes from the Elements of Computing Systems book, Building a Modern Computer from First Principles, the Nanda Tetris Companion. Technically, I probably shouldn't be streaming this, but it's an interesting project for me. If you are taking the class, don't copy my code. Like, don't deprive yourself of that learning ability. Again, I probably really shouldn't be streaming this, but I am. Breaking the rules. So I was going to show you a little example of the assembly, or of the assembly syntax, but I think I might actually forego that. What I am going to do is totally rip off my own... Oh, shoot, what just happened? Oh, what? No, okay. Screw that. I don't care about Java versions. What I am going to do is kind of rip off my regular expressions from my C++ version of this, and then change them as I need to. So, whoop, that was for L command. So, L command regex, paste that in. I probably really actually don't need all those. Let's see. There we go. Okay. I don't need to escape anything special because it's a raw string, so that's nice. What I do, let's see. Let me consult the book. I need to refresh my memory. This has been a few months since I wrote the first version of it, so bear with me for a moment while I flip through a book you cannot see. I know, ironic, right? Okay, L is a label, that's right. So it's something, it's a parenthesis, and then some stuff enclosed within it. So we shouldn't need to escape the parentheses. If it fails, you know, we'll figure it out, but shouldn't need to escape the parentheses. And inside of that, we just have a capture group with a dot star, so we can access that later. And then for the A command, the address command, I believe it is an @ sign followed by some sort of wildcard characters. And if we look at my C++ version, that looks correct. Indeed it is. Yes, that looks right. Though I'm not sure why I parenthesized the heck out of that. Well, I did a capture group on the inside. That's an interesting regular expression. I don't remember what I was doing. I don't remember what I did. But that's okay, because we're going to figure this out on our own, together, or not. We'll see. So what I am going to do is I'm just going to make a naive assumption, and if it's wrong, it's wrong, and I'll fix it later. But hooray for naive assumptions. That's what we'll be doing. And then, like I said, if it's wrong, and we'll fix it later. So, oops. What am I doing? Okay, cool. All right, so let's take a look at this and do some stuff. Okay. These multiple monitors just aren't set up right, so I keep like getting myself confused about where things are. So bear with me, sorry. Where's my cursor? There it is. Okay, so for this, we're going to make the naive assumption that it starts with an @ sign, and then from here, we're going to do a capture group, and inside, we're going to have words, or we're going to have digits, and that's going to be, you know, dot star number of times, I suppose. We can test this regular expression for legitimacy. rest regex. Here we go. There's this website out there called regexer.com, except I didn't spell it right. So if we use this, we can check it. So what it looks like is a label is something like that, and an A command is some sort of like at R1 or at end or at loop. So what we did for our loop command is we have a parenthesis, which actually we do need to escape because that's a special character in regular expressions. I didn't even think about that. And then inside we have some sort of word star, and then another, I think that's the regular expression we used. Kind of, though I do need to escape those parentheses. Inside I allowed anything, which is technically correct. So instead of this, we can just substitute a dot there, and that captures everything. So there's our L command regular expression. And then for our other one, we want an at sign. We want a capturing parenthesis, and then we're going to do words or digits, and we're going to hit that as many times as we need to, and that capture group gives us the label. Okay, that's good. That's what we want. So this regular expression verbatim is what we're going to stick in the code. Whoops. Yes, leave the page. That's exactly what we're going to stick in the code. So we'll just do this, and we'll paste that in. I think the only difference was a differently placed parenthesis. So, you know, it works. And let's go ahead and check to see if that compiled. Looks like it did. Let's see. What am I doing? Let's just do cargo build. Okay, everything builds. That's good. That's good. And if we test, all the tests pass, though the one for the parser is really just a token test that doesn't really matter. But we're looking okay. So that's good. The parser creation is okay. Though this is a little long, so stylistically maybe we clean this up. Let's go ahead and stick this on a new line. Whoop. And that. And that. And that. Okay, so we've created a new parser. Let me just re-indent that. Okay, everything looks good. Let's just run a re-indent on the entire file. Okay, everything looks good. Cool. So now the big thing is to actually write the token type implementation. So what we're going to do is we have this token type enum, which gives us L, A, or C command type. And so we take in some sort of ref string, and we do some sort of regular expression checking on it, and then we finally, check and see if that works, give us the command type. So what we're gonna do is, I guess we'll say, oh, there's no parentheses in ifs. This is one of the things that keeps tripping me up. So we're gonna say if, and we'll go with token. No, we want the regex self dot. I don't remember the regex syntax off the top of my head, or the API. So let's consult the documentation. That's what documentation is for. I'm gonna put this on a different screen for now, and there we go. I need to fix my monitor layout eventually. I just haven't yet. So let's see. Okay, cool. All right, so what we want to do is we want to look at, okay, so we call the regex and then the is match, and that should return true or false. So let's try that. Let's see, is match, and we're gonna send in the token. So if it's a match, what we're gonna do is we're gonna return, actually we don't need to return, we don't need to explicitly return. We're just gonna say L command, and we're gonna say else if. Actually, let's not do an else if. Let's do another if. Self dot what is it? A command type. A command regex dot is match token. Then we go A command. Else, we're just going to return C command. That's going to be our default. It's also a little more difficult to test for. And let's, let's double check that we didn't mess anything up. Oh, I should probably restart guard, but, oh, that's right. Where's this? 0. Okay. Yeah, so what we need to do is, let's see if we can, nah, we won't do that. Let's not deal with re-exports. What we'll do is we'll go token type at the beginning. Whoa. Oh yeah, that's right. Nope. Okay. Shoot. Alright, brain fart. We're good. So, that should build now. Cargo, build. No, okay. Let's see, mismatch return type. Expected, blah, found, syntax, parse, token type. Okay. So we have a return type problem. Though, that should work. Except, let's check. Hold on. Alright, so expected the unit type, expected no type, essentially void, and it got token type. What's going on here? Pretty much across the board, anytime I use token type, it errored out. Okay, 0. We want to return a token type though, which is an enum up there, so that doesn't make any sense. I mean, it's like saying, you know, option token type, like is what we want to do, but instead we just want to return token type. I don't know why this isn't working. It seems like it should be apparent to me. Unless I do actually need explicit return, which I could try. But I'm pretty sure it has to do with a different return type expected. No, apparently not. Okay, I could not just leave that as is. I had to explicitly return. That kind of surprises me, but that's okay. We can work with this. Since we are using explicit returns, I am going to stick semicolons in there. So now, actually what I really should have done is written the test first, but we're going to write a test after. And so we're going to test, we're going to say function test, it always has test before it, so we're going to say function, we created a parser, let's say recognizes token types, and so what we're going to do here, so we're using superstar, which means we're using everything in the namespace above, so let parser equal parser new, ooh, okay, wait. Okay, one thing that I am going to do now is, now that we have 2 parser news, I'm going to create a function setup that returns a parser. And so what we're going to do is we're just going to return parser new. And what this allows us to do is say setup. Just allows us to get rid of some of the boilerplate. Okay, so that test should pass as is. It looks like it did, because it's really not asserting anything yet. So the next thing we're going to do is we're going to say parser parse, and we're going to send in some sort of dummy token. So we're going to say parser.parse, and let's say we'll send in a label called loop. But what we're going to want to do is use the assert eq macro. And we're going to say parser parse, and what we're expecting is token type L command, and that's what we want. And so we're gonna try each one of them. We're gonna try an A command. Say let's say @I, and that's gonna be an A command. And this one we'll say as a C command. Say m equals m plus d. And then I guess I just saved it, so let's see if that ran. Unresolved name, token type, a command. Alright. Well, I thought I included everything in that outer. Let's see what happens with that one. Unrecognized L command. Okay, nope, that's fine. So we have some sort of unrecognized imports going on here. So let's say use super parser and use super token type, because that'll be in the module above, is what the super keyword tells us. And now we have a problem. Alright, what's the problem? We have something going on with the expansion of the macro. Here. Oh, this is going to be easier if I do this myself. Okay, this long has to do with the expansion. Let's figure this out. Expected. Oh, okay. Yeah, that's what's going on. I'm testing the function thinking that it does one thing, but it actually does another. So what I actually want to do is a pass through on that token type function. And I kept it private for a reason, but I guess it can be public. Let's make it public. So what we're going to do is, instead of the parse function, we're going to say the token type function. Like that. And actually, let's just whoop. There we go. Alright, I would get it eventually. And we'll check it again. Something's going on here. Something strange is going on here. Though it could just be me not completely, like, still, you know, figuring out Rust. Oh, shoot. Star. Stop typing weird characters. Oh, user? That's nice. Okay, now we fixed it, but we have a problem. Failed to resolve use of undeclared type or module token type. Private type and exported type signature. Oh, okay. And the plot thickens. That should be a public enumeration. And that still shouldn't work. Okay, it looks like because there's no trait implemented, it can't check for equality, the left and the right, given the, yeah, binary operation equal cannot be applied to type syntax parse token type. So let's see if we can deal with this. Can I automatically derive partial EQ and EQ? I don't think so. I'm guessing I can't. It looks like I actually need debug instead of partial equality and equality. So let's check that out. This may not work too. We'll see. Okay, here we go. Right, okay, binary operation can't be applied. So I probably actually do need partial equality and equality. So, though I think I only need partial equality because I don't need that to be reflexive. Though I might actually. No, that looks okay. That passed the test. Looks like everything's fine. There's some background noise going on too, so sorry about that. That's actually really noisy. Somebody's vacuuming. Sorry about the background noise. Okay, cool. So that worked. I want to try one more A command because there's other types like R2. And that worked out fine too. Cool. So we have detected the command type. We get the, so the parse function can work now. So this is all good news. We're getting somewhere. This is all great news. And let's see. So from the parse function, what we're going to do is we're going to call the token type. or we're gonna grab the token type, we're gonna match it using a match block, and depending on that match block, we're gonna do something different. So the way I kind of envision everything fitting together, if we go into the main.rs file, this is pseudocode. But this is kind of how I see everything working. So we have the lexer created. So we take the lexer, we go lexer.iter, and then we go map. And we say, here's our token. And what we're going to do is we're going to take each of the tokens. Actually, we probably need to say let parser equal parser new. Let's delete that. That was some original pseudocode. I'm kind of redoing it. So you go token, and then we'll say parser.parse token, and then we're going to say .collect, and it'll be like a vector of strings, because each one will be a different line. And then from there, it's going to be like, output file .write, and it'll be, let code equal that, and then we're going to write code out there. Now, obviously, that's all pseudocode. Some of it does work, some of it does not work. I'm not entirely sure. I know what does and doesn't work, but I'm not concerning myself with that yet. But that's kind of what I'm aiming for, is like a little 3-line, driver sort of program that does the core of it. No, it's a vacuum cleaner. Sorry about that. Somebody is vacuuming in the area. I apologize about that. I can't do much about the background noise, so again, sorry. But that's kind of what I'm aiming for. So I'm doing the best to kind of follow that idea. So I guess we get back to writing the parser. So now that we have that, what we can do is we can go back to the match block and deal with this. And so if the token type is, say, an L command, which I totally spelled that wrong, is an L command, we can do something. If it's a command, we can do something else. And when it's a C command, we can do something else. Now, that should be exhaustive. And that's the one thing about these match blocks, is like pretty much every run-of-the-mill functional programming language, Rust also ascribes to that match must be exhaustive. Actually, I guess in Haskell, it's not a hard requirement. You can create non-exhaustive search patterns. It's frowned upon, but it's possible. But Rust likes to borrow quite a bit from other languages. I've noticed some Ruby influence in it. There's obviously the C and C++ influence. There's some Haskell and some other pure functional influence too, like with those iterators and those map functions and things. So there's a lot of cool stuff that goes on with Rust. And I really like it so far. I'm still getting the hang of it. Like I've mentioned earlier, I've been following it for about 1.5 years or so. But I've only seriously started writing some Rust code probably within the past 3 or 4 months, mostly because I didn't know what to work on before now. So, hopefully it's kind of interesting stuff to take a look at and watch somebody write Rust code. But it's definitely an interesting language, and I'm intrigued to see where it goes. It's really cool. So we'll keep going. Probably going to go for about another 20 minutes streaming, I think. This was kind of just like a talk things out to potentially an audience, see what happens, see if anybody has any ideas, bounce some ideas off people who might have any, or just see who's interested in Rust. So for the case of an L command, that's going to become a symbol. So what we want to do in this first part where we don't deal with a symbol table, we want to do something cool. Let's see. Yeah, so there's a certain number of predefined symbols in this assembly language, and then there's a certain number of symbols that the user can create. So in the first iteration where we don't care about symbols, what we're going to do is we're going to just totally skip dealing with L commands. So for now, I'm just going to throw in the unimplemented here because It is unimplemented at this current time. We'll implement it when we start worrying about a symbol table in the second sort of iteration, because we're doing this in baby steps. The A command is for recalling some sort of symbol or decimal number. That shouldn't be too bad. And our C command is pretty much everything else. So what we're going to need to do is... So the L command doesn't matter. Yeah, what we're going to want to do is start worrying about our C commands, I think. Well, we can start with A commands. Those are pretty simple. So, yeah. Oh, here we go, A instruction. An A instruction is like at value. And so it is, everything in this language is 16 bits. It's very toy, very simple. So what we're going to do is A commands start with a 0 out in front, and then have 15 bits of the value, so it can be a 15-bit value of some sort. And value is either a non-negative decimal number or a symbol referring to such a number. So what we need to do is we need to extract whatever that is, whatever that number is, and then convert it into some sort of binary representation. That I'm not sure whether Rust has something built into the language for that or not, so we'll have to find that out. And then C instructions are like some sort of command instruction, I guess. So you can either reassign values, of which there's this hard-coded 6 bits for, or you can have a jump, and there's a jump table that shows that. But there's also a destination if you're doing some sort of arithmetic assignment, and there's also a jump table, again, like I said. So in total, that's another 15, or that's it's actually only 12 bits. There's 3 jump bits, 3 destination bits, and 6 comp bits for some sort of computation. So that's kind of nice. But well, it looks like it dropped to just 1 viewer, and I think I'm at a point where I need to do some more intense thinking on how exactly I'm going to go about doing this. So I actually think I'm going to end the stream here. But it's fun and it works, and I think I'll do this again sometime. But I think I'm going to end it here. I'm going to try to get some more of the hardcore stuff done inside of this program, and maybe come back and stream it later sometime. Well, I mean, I can keep going. Like, I don't have to stop. I wasn't sure if anybody was interested, but if you want to keep seeing it, I'll keep streaming. In some ways, talking out loud, even if it is just to myself, helps me think things through sometimes. So in the event of an A command, that should be pretty simple and straightforward to do. Let me look at the Rust API, see if I can convert like a number to binary or something. I remember in C++ I used some sort of binary. Let's see, number to binary. There's a really nice, it was like 2bin or something. It was really great. Oh, it was standard bit set. That's what it was. And you gave the number of bits in the template argument, and the argument you actually gave to standard bit set was the number you wanted to convert. Then you could convert that to a string if you so chose to, and blah blah blah. Anyway, it was really nice. It was actually quite nice. Let's see. Binary digits. Yeah, it's kind of boring right now because I'm not showing you how I'm researching stuff, so yeah, bear with me, maybe a little bit. Okay, so that is an option. That is a potential option. Let's see. Hey, Pokey, do you have like any interest in Rust, or have you used it before? I'm just curious, like, what your background is of any sort of programming or whatnot. But let me know, because I'm interested. I'm curious to see if you've written Rust, or you've worked in other languages, you're interested in Rust, or whatever the case may be. But just let me know, because I'm curious. I'd probably format that using the standard format. Yeah, that actually might work. There's a format macro which lets me print something and put an argument in, and I can format it as binary. and then I get a string out of it. So, huh. Oh, cool. Okay, so you watched another guy. Yeah. So what do you typically like work with? What do you typically work in? Um, Personally, I like C++ and I like Rust. I like kind of being low level and close to the metal. I haven't seriously done anything in C before, but I think that's also an interesting language. It's really simple. But I like working in the lower level languages because I like the power. But I also, yeah, I work in some high level languages too. They're just not my favorite thing to do. And personally, for me, I'm a junior in my undergraduate program for computer science, planning to pursue grad school after graduating. And the topics that interest me the most right now are like parallel computing and high performance computing. And so those typically target low level languages. And so that sort of area of research is what I'm hoping to do my thesis in for my master's degree. And then from there, I'll evaluate whether I want to enter into industry or continue on to a PhD or something. I'm not entirely sure what I'm decided on, but I do like hanging around in the low level languages and stuff. But I just like the power that they give you. Oh yeah, functional. It is. It's high level, but it's a totally different paradigm. It's not like high level in the sense of you write Python or Ruby. It's high level in the sense that in the sense that it's just a different paradigm to write in. You kind of free yourself from the von Neumann architecture. I've played a little bit with Haskell, but that's the most I've done with functional programming. I've never really done anything huge with it. It's for me, it's just this crazy departure from my normal thought process. It's just kind of strange, but it is functional programming definitely has its places, and it's definitely interesting. I think it, yeah, high level in the sense of abstraction. Yeah, that's true. But I think it's interesting. I think it has its place, and I think we'll see it kind of occur more or appear more in code because it has certain good qualities to it. Because it's functional, you have very few side effects unless you specifically specify them. That was a redundant sentence. Unless you are explicit, there are no side effects in a functional language, and so that cuts down on the number of bugs that can appear. So it's kind of it's interesting. I have a class this semester that kind of dives into functional languages, but I kind of have investigated them myself before. But okay, so for this A command, it's a literal value. So what we're going to want to do is we want to return some sort of command string. Well, let's say we'll call it opcode. Let the opcode, and we're just going to allocate a new string. Which then also means that we need to return some sort of string, because we're going to collect those at the end. And for now, we're just going to return 16 zeros. Just to mock it. Okay, so actually another. Oh, you did your bachelor's thesis on Scala. Yeah. Okay. Yeah. Yeah. It will. And I expect that to happen. The class I'm taking this semester on parallel computing is all like C or C++ or Java because that's mainly what the professor knows and what he's comfortable with, which is going to be a nightmare. Be nice if he would have adopted something like Rust. But yeah, the strange part is that for my program, I don't have to write like a thesis for my bachelor's. We had a capstone project. But the way that my school works is you actually did it over the summer, and it was kind of like a client project for a company in the area. And so I actually did it this past summer. I still have about a year and a half left of classes to take, but I had all my prerequisites out of the way to do the capstone. So that part of my program is done, but I still have about a year and a half left. And then I'll dive into grad school after that. So with this A command, what we're going to do is we want to probably match it again to the regex and then extract the capture group out to get the digit. Then take the digit, format that digit into, actually we want to check if it's a digit because it can be a variable too. But then we want to check that digit, and we want to check and see if it is a digit, and if it is, then we're going to convert that number into binary. If it's not, we're going to go into the symbol table, but we're not dealing with a symbol table yet, so everything's going to be hard-coded values, which is nice. So this first implementation can be very simple. I oftentimes get ahead of myself, and that thought process that I just talked through is just one of the ways that I really do way get ahead of myself. And I'm actually happy that I kind of talked my way through that, because otherwise I would have tried to make things too complicated too early on. So what we're going to do is we want to extract a capture group. So how do we extract, or how do we get capture groups from regular expressions? I have vaguely worked with the regular expression library, so. Okay, cool. So, interesting. All right, so what we're gonna do is let's we'll say let capture equal, and then we'll do self dot a command regex dot captures on our token, and we'll unwrap again because we're doing simplistic error handling. So if it does return a none, it'll panic out, or if it returns an error, it'll panic, and program execution will end there. It's not the cleanest way to do things. Definitely not the cleanest way to error handle, but probably one of the quickest ways to make sure that things do or don't work. And then from here, we're gonna do. We use an at function to get the capture group. So let's say let digit equal capture.at, and it's the 0th capture group. It's the first capture group. Which this is what I was saying was interesting. Most regular expression libraries in any other language has the 0th capture group as the entire like matched string, and then the first one is the first capture group, the second one is the second capture group, index 3 is the third capture group, and so on. Whereas 0 is that full match string. But apparently with the Rust regular expression library, the 0th is that first capture group, which is actually really kind of nice. Kind of strange though, because it's so different from your typical capture groups. But so because we know that it's going to be a digit, let's see. Say let bits equal format. Oh. I still am not sure if this is going to work. I think B is the binary format. I'll double check that before we actually try this out, but feed in the digit. And then what we're going to do is we'll take 15, we'll take the last 15 bits from that. And yeah, this is a good question what this is going to return. I'm not entirely sure. I'm moving into uncharted territory. Yeah, the whole Capstone project does make a little bit more sense because it's some practical experience. Actually, the Capstone project I did was a web application, which wasn't terrible, but it wasn't the most interesting thing in the world either. I think the web is interesting. I don't think the problems are sufficiently interesting enough, at least like forward-facing websites aren't interesting enough to keep my interest, but you know, the web is definitely going to become like the next big thing. Whether that's a good thing or a bad thing, I'm not entirely positive. I can't see the future, but it's just the way things are moving, make everything a web application. So, okay, I am moving into totally uncharted territory. Binary. Okay, yeah, so that works. Format. Interesting. I'm still not entirely positive that format macro call is gonna work. Oh, no, that should, I think. I can always print brute force it, but the regex groups, but yeah. It's child's play compared to that. Interesting. But yeah, the regex groups is interesting. It makes more sense to me too, because I think the first time I played with regex with standard regex in C++, I got tripped up by the fact that 0 was the whole matched string. But again, I still don't know if this is completely right. So I guess we'll find out what happens. For now, I'm actually just going to print out bits. And I want to test this, so let's write a test, which I probably should have done earlier. Function, we'll just test the parse output. Okay, and let parser equal setup as usual. That setup method, you know, comes in handy. I love that I have the forethought to do that all the time. And I actually do have a snippet for assert equal. I should use that more often. What the heck just happened? That is really strange. Apparently my macro doesn't work. Try it again. Okay, there we go. Something went wrong with that first time. Weird things. Really weird things. So let's do parser.parse. And let's say at 5. Now, for now, I'm just going to end up with 16 zeros if I want to actually pass the test. And it looks like, oh yeah, okay. So we have some errors that I assumed my code was okay. It is in fact not okay. But we only have a few things to do. Let's see. So the first one is I'm returning a type string, but in reality returning a string literal is type str, whereas what I want to do is type string with the capital S. So what I need to do here is use string from, and that will fix that problem. But the second problem I have is that core format binary, that trait is not implemented for core option string, which is interesting. So what I need to do is convert the string to a digit and then the digit to binary. So I need to do a couple different type juggles, and we'll figure out how to do that. To, yeah, say integer, some sort of integer size. Convert a string to an int. Oh, that's right. There's a parse function. I should have remembered that. I've used it before, like once or twice. So what we'll do is we'll say digit.parse, and I think we can reliably say that it's going to be, I think it always has to be a positive number. If it is, then I'll make it an unsigned. If it's not, I'll make it signed. I just want to double check on that. Oh yeah, a value is either a non-negative decimal number or a symbol. Okay, so it's non-negative, so because this is a toy 16-bit CPU, I think we can safely say that an i32 is going to be sufficient. Let me just double check the API that I'm trying to mess around with. Okay, so that should work. So we have that, and that's a function call. So I think that should be better. Okay, no it's not. Okay, and I think it's because I'm dealing with a ref string instead of a string. The two string types can actually get kind of confusing in Rust. There's a reason why those exist and they're useful. It's just kind of a pain. There's a lot of cool stuff coming down the tubes for Rust. It's just not quite finished. There's a lot of stabilization still happening, which is cool. It'd be nice if it was done being stabilized, but it's still, you know, there's a lot of cool stuff. Let's see. Sorry, I'm looking stuff up. What's that from February 1st? The problem too are the number of like Stack Overflow questions that were answered in like the 1.0, in the pre 1.0 days, because Rust only really stabilized back in May. So it's only about 3 months old, stable. So there's a lot of answered questions from the past that don't necessarily apply today because of changes that have happened since then. So there's always kind of that figuring out what the equivalent would be. Oh yeah, I have this program called Dash that lets me look up documentation. So I found something that says the standard string extension, but I'm not seeing anything. I think they must have deprecated that, which makes sense. There's a lot of deprecations that happened. But so if I look at the regular string primitive type methods, there should be a parse. There was a parse. There may not be anymore. You know what? I can search for that. Parse. Yeah, okay, so there is a parse. Oh yeah, but using the from str trait. Wow, that's really spinning up that fan. Whoops. Wait, I don't want that. Okay. Let's see. Let's see what we can do. Oh, wow, okay. I just realized I had everything set up wrong. Like on my desk wise, but yeah. Epiphanies. Yeah, it is. Only OS X. OS 10. I used to call it OS X for the longest time, but I know it's OS 10. I don't know if there are any Apple fanboys watching this, but please don't kill me. I also am kind of an Apple fan nowadays, but I switched to a Mac from a regular Windows machine, and I've never really looked back. I have to say they're super nice. They're expensive, but they're nice. Okay, so I think if I import the from str trait, everything should be right in the world. Because if we look at that interface right there, it's parse using some sort of generic F, which implements from string, which is in, well, it says collection string from string, but I think it's re-exported within standard somehow. I just need to find out how, because collections is a separate module, or is a separate crate, and if I try to do extern, collections, it's gonna complain at me. I've tried similar things like that before with with the collection crate. It doesn't like it, so let's see, trait. Oh yeah, standard str from str. So I think yeah, so if I import this, I should be able to use the parse function. Maybe. I'm not positive. Yeah, shoot. No, that didn't work. Okay. Primitive type. Come on. There we go. Parse. See, the example shows that should work. Wait a minute. I think I know what's been going on. Yeah. Oh, yeah. No, it's always been there. I was reading that wrong. I was looking at this type, and yeah, though even with that type, it should be implemented. The problem is that it's not implemented for the option type, for that optional type. I've been doing it right the entire time. I don't need that import. If I rerun cargo build, yeah, so we have the same error, core option, and the reason why is because it's wrapped in an optional type, so it's like some or none. So 36, I think. What I need to do after this is probably call an unwrap to unwrap that. Again, really, really crappy way to fail, but a quick one. Oh wait, never mind. Oh, core option string. Okay, so maybe there's a different type going on here than I initially thought. Oh, because it's a capture group. I forgot to unwrap that. That's why. Yeah, everything worked. I don't think this should work. I can't imagine it would. Yeah, I didn't think so. So that works. I wonder if I can get rid of unwrap. Probably not. Yeah, no. Whoop. Alright, so what if we test it? Will we fail anything? We failed something. Okay. Oh! Parse in invalid digit. Interesting. Why? Alright, so we have an interesting result. We have something that we want to figure out why that's going wrong. One of the things I can do is, what if we just print out the... What if we just print out the digits, see what's going on with that? I'm never getting to bits there, so we'll just comment that out for now. But if we go to test, cargo test, there's a... shoot. I think it's no capture. It'll let me see things that print to the console. Let's see. Failures, one panicked. Okay. Oh, no, never mind. They lied to me. The documentation lied to me. If we look right here, that capture, like kind of where I'm highlighting, my highlight sucks. I just realized that. It's like transparent on an already light background. But anyway, it printed out the whole token instead of what I thought it was. So apparently that doesn't work. Oh, shoot. Nope. God dang it. Okay, there we go. Okay. Apparently I do want capture group 1. Liars. Oops. Whoa. Seriously. So capture group 1. There we go. So if I try this, hopefully it works. And it did. Okay. Yeah, nope. They lied to me. Or I read the documentation wrong. Both are equally likely. Not really. I probably read it wrong. That's probably what happened. Okay, so I want to see what happens when I print the bits. Same thing. 101. Okay, cool. So it gives me the number of bits in the number. That is binary 5. Gives it to me as a string, I believe. I wonder, is it a string or is it an str? What if I could type coerce that way? Will it complain? It might complain. No, it doesn't. Okay, so it allocates a string. This is good. Okay, so if I type allocate, or so what I'm gonna need to do is fill in n number of bytes up to 15, or n number of bits up to 15 in that string to properly return the A command. But otherwise, A commands are essentially done until we start messing around with symbol tables. Then we do some different things, but that's, kind of for a different time. Also, fun fact, I've been streaming for about an hour and 10 minutes at this point. It's about 4:50 in the afternoon. Probably gonna... Actually, yeah, I think I'm gonna call it quits around 5 o'clock. There are some other things I should probably work on today as well. But I think my plan is to stream programming every Thursday at some time in the afternoon or the evening. I think my channel says that I'm going to do it Thursdays at like 7 Eastern or 9 Eastern or something. I don't know what the schedule is going to look like, but I think I'm going to do something like this every week. I think it's really cool that Twitch added a programming category. I think it's interesting that certain people work on different... Oh, it's going to be 1 a.m. there. Okay. So, oh yeah, because you call it uni, so you must be over in, I would assume, the UK or somewhere in Europe. So I think you're about 7 hours ahead of me. Yeah, I think, because I'm -6 and I think you guys are +1. UTC because screw it. I don't like GMT or British Summertime for that matter. UTC is great because it never stops. I think I've heard of live coding. I might think about doing stuff over there. I'll have to check it out. I think I've heard of it. I don't remember for sure. I think it's more suited towards programming than Twitch, mostly because Twitch started as gaming. Though didn't Twitch own Justin.tv and they shut that down or something, I think. But it used to be that if you were programming, you'd go over to Justin.tv. Unless you're doing some game programming related, then you would go to Twitch. I don't remember. Point being is, if livecoding.tv is the better site for something like this, then I might do it over there instead. Okay. I probably can format the number of bits that I actually need using that format macro, because I think I can. Let's see. I'm pretty sure I can. That's interesting. I don't know what that means. I'm reading documentation. It's kind of strange. But that's good to know about livecoding.tv. I'll check that out. Oh yeah. Interesting. Their streaming schedule. What is their streaming schedule? Is this like you have to sign up for it? A streamer program. Interesting. You only need 15 viewers to get featured on the index page. Interesting. Huh. Okay, well, let's get back to actually doing things that matter. The format trait. Show me the magic. I want to be able to specify the number of bits in the binary. Let's see. Oh! Wait. Okay. I don't think this will work, but it's worth a shot. I want 15 bits. I have no idea if that's going to work. I don't think it will. Yeah, that's what I thought. I don't think it works the other way either. But it's worth a shot. Oh, it does. Except yeah. Okay. It kind of worked to give me like 15 spaces. Kind of. Not exactly the way I want it to work. Yeah, okay, alright. So yeah, anybody streams anytime. That's what it looked like. The regulars must be the people who get 15 or more viewers, but I think it's an interesting concept to watch people write code. Just because it's kind of normally boring, especially if they don't talk a lot. Some people do and don't to certain degrees. Some people can talk and code at the same time about something completely different. Some people can't. Some people talk the problem through out loud. Some people don't. Some people write some code and stop for a while to answer questions. Again, it's all different. Game streaming is also something that's kind of cool too. But let's see, Rust convert int to binary. Bit length. I don't know, something like that. Huh. Yeah, see, that gave me the same thing for Rust's print line. Alright, let's go back to that format trait page, see if I can figure something out there. Let's see, format macros intended to be familiar to those coming from C's printf /fprintf or Python's string format. blah, 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 positional parameters, named parameters, argument types, formatting traits. B is obviously for binary. Okay, it uses the display trait. Format display, format debug, derive debug, which I think I had to do for the token type thing. Syntax. Syntax for formatting language used for the formatting language used is drawn from other languages, so it should not be too alien. Yeah, I still think it kind of is, but that's okay. Oh, the actual grammar for the formatting syntax is, and then they show you the formatting grammar. That's interesting. Yeah, that is. It's interesting to see what somebody else's thought process is, or what they're interested in working on. I agree. Me, this is kind of a toy project. It's not practical at all. I actually have hard times coming up with practical projects. So I usually just kind of spin my wheels. But okay, so width, precision, what's going on here? Oh, okay, format spec goes fill. Oh, for a character. Oh, okay. And let's see. Format string. Yeah, the grammar is interesting to read over because it is a well-defined grammar. It's not like the black magic that is C's printf function. So this is kind of interesting to see how it's different than something else. So format string has some text and some format text optional. And then format has an argument and then a quote and a format spec. And the format spec has fill, align. Okay, I think this might work to do what I want it to do. Because that 0 preceding it is the fill, if I'm reading the grammar right. And it compiled, and it did not fill. Nope, okay. So it's a character. Interesting. The fill character is provided normally in conjunction with the width parameter. This indicates that if the value being formatted is smaller than the width, some extra characters will be printed around it. The extra characters are specified by fill, and the alignment can be of one of two options. Less than sign is left aligned, up the caret is at the center aligned, and the right is right aligned. Okay, so I should be able to achieve what I want through some combination of this grammar for this format trait, which is good to know. Yeah, that's a good point. I probably should. I pulled up the documentation in a separate browser window, mostly because I keep forgetting that I actually have it here. But here, I'll show you what I was looking at. So I was looking at the standard format here. And so what I'm talking about is the grammar. Thanks for bringing that up, because you're right, I should. The grammar is this right here. There's different parts to it. And format spec is what I'm looking at. So we have a fill and we have an align. We have a sign, which I don't care about, and it's optional. You have some sort of... maybe not. Width. Something over here. See, I'm still trying to understand this this precision, or this format here. :08. Oh, okay. Maybe I have a better grasp of this now. Maybe I don't. 015B, and I want it to be. Hold on. I want it to be maybe left aligned with the width column. I don't know. I guess we'll play around with that. We'll see. Something like that. I don't know. I don't even know what I'm doing right now. I'm just testing things to see what sticks. Hey, that I think worked, because we have that right there. I think that's 15. I would imagine that's 15 characters. Yeah, it looks like 15 characters. I think I got it. Okay, that's actually good to know. I had no idea that it had such a well-defined grammar that is relatively regular. Hopefully showing you the documentation page kind of illustrated my thought process. But now that we have that going, I'll take that out and we'll just return the bits. And actually Rust is kind of an expression-oriented language anyway, kind of like Ruby or something. So instead, I'm just going to leave opcode there. And actually... Oh, you know what? No, I don't want to do that. I do want that just to be string new. Because if it's an A command, what I'm going to do is I'm going to say, I think push I can use on a string. Let's check it. Strings. Does it give me? No? Okay. Oh, here we go. Standard string. Yeah, okay. I have this program here. I just keep forgetting to actually use it. I've had it for a long time. I've just never gotten into the habit of using it. And I forget I can search that. But okay, push str, push the given string onto the string buffer. Okay, good to know. So what we can do instead is go push str, give us the prefixed 0, and then from there we will say push. Oops. I think opcode plus equal bits, maybe, perhaps. We'll find out. And then I want to change the test, because if we have 5, what it's going to be is those last 3 digits are going to change. It's going to be 1. Whoa. Oh, shoot. It's because 101. And if all goes according to plan, no, okay. Okay, so the binary assignment operator can't be assigned a standard string. I know you can implement the add trait. I didn't know whether or not string used the add trait. ADD. Yeah, okay. Impl add for... Let's see if there's a string binding implemented here. I mean, I could do it myself if I wanted to. Oh, and somebody's playing piano in the background too now. That's great. It can kind of get a little noisy, but okay, add does work, but I think what I actually would need to do is not this shorthand. I would need to do that, and I think that should work. Oh, wait. Interesting. So bits is a total string. Here, we'll hit up Google results. Wait, there's a concat? Okay, that's kind of cool. There is a concat macro. Cool. There are macros for everything. Whoop, shoot. There we go. Whoop. What? Expected a literal. Huh. Dang it. Oh, because it takes the literal. Okay, yeah. I know what it's saying. Okay, wait, strings. There might be a join operator. Oh, no, because then it has to be a list. Okay. We're gonna totally go with the most simple language possible and say add 2 strings. How do you concat these 2 strings? Alright, Reddit, show me. Okay, so the other side must be a ref string. again, the different types of Rust strings tripping you up. And I think that should maybe appropriately deref. And it looks like it did. It did. Okay, so that worked. That passes the test. Sweet. So then for C command, we'll throw in the unimplemented macro once again. But what we will do is say opcode push str. And C commands start with 3 1s at the beginning, like that. And then we have to compute some, semicolon. Then we have to compute some other things, like the destination, the comparison, and the jump, if there is any. So there's going to be a little bit more involved in the C command. I think for the A command, I'm going to end up extracting that logic out into a separate function inside the parser object, or parser struct, just because I'm going to have to. But I think for now it's 5:05 and I'm going to stop streaming. But thanks for watching. It's good talking to you a little bit, Pokey. And I think I'll probably try it again here, maybe next week. But I might also check out, what is that, livecoding.tv that you recommended too. So I'm going to call it quits here. Thanks for watching. Hope that, Rust is a little bit less of a mystery and a little cooler, because I think it will have its place once it's fully matured. And I want to be one of those people that's like, oh yeah, I've been using Rust for a long time. I also wouldn't mind contributing to the core project sometime in the future too, once I get a little bit more comfortable with it. But thanks for checking out my live stream. Thanks for chatting in the chat box a little bit. It was good hearing from you. So thanks to everybody else who watched over the course of the stream. But